Hello, my name is Vasilisa Ignatova, and I have spent the summer working in the Zoom lab developing a scaled-down, low-power catapult. So in nature, many different organisms have evolved to possess impulsive mechanisms to achieve jumping and striking movements. Examples of these organisms include fleas, frogs, mantis shrimp, trapjaw ants, jumping spiders, and many more. So in studying these creatures, we have been able to develop a lot of work in latch-mediated spring actuation, which is a field where we are looking at how these small organisms are able to develop movements that are way more powerful than their muscle strength alone should be able to develop. So the mantis shrimp is one of these creatures that I've already mentioned, and we study it because it is known for its ultra-fast, powerful punch. So previously, researchers have taken the shrimp, analyzed it, and been able to create a mechanical model to mimic the movement that it does. So on the left, you see the mantis shrimp, and then on the right, you see the mechanical model that the researchers created. So my objective this summer was to take that mechanical model, convert it into a catapult that is able to throw markers into its environment, and then be able to have that model be scalable and compatible with autonomous low power systems through actuator design. And to add on to that, I wanted to see if I can add control to this impulsive system by modifying the arm design of the catapult to be able to launch markers to different distances. So the 3D structure of the catapult was constructed using Papa Mem's fabrication technique, which is where you have everything laser cut on piece of paper or whatever material you're using, and then you fold it to make your 3D structures. So in my case, I had 5 layers of rigid, adhesive, and flexible material. You could see the breakdown of the materials on the right. And I put them together and then used a laser cutter to cut out the final shape of my catapult. So on the left, you can see all of the materials that went into creating this model. You have the main shrimp body, you have the bucket, the springs that I use, the base, and the laser cut springs. And then on the right is what my catapult looked like when it was assembled. This is a closer look at the distance control mechanism. So basically the arm was a sliding arm. The bucket was connected to a plate that could be pulled and pushed. And you have SMA here attached to the bucket that would be able to pull the bucket into different positions on the arm. And to make the bucket easier to slide, there's an embedded piece of stainless steel that was incorporated into the arm to help decrease the friction. So a large part of my project was the actuator design that would activate the entire mechanism. So the actuators that I was using were springs made out of shape memory alloy, and shape memory alloy basically retains its shape when heated. So I was able to laser cut the springs, and on the left there's an example of the actual actuator that I was using. I collected some data on actuators. On the bottom here, you see a chart of how many amps it took to heat the actuator enough to activate the mechanism. And you can see the different data on how fast the mechanism would actuate given a certain amperage. And then on the right here are just more data on power requirements and degradation amperage. So here you can see a video of the catapult actually catapulting. And then one of the experiments I did was switching out different masses that were launched and seeing how the launch distances would change. I also did a similar experiment with changing the bucket distance on the arm and seeing how far the object would be launched. That is it for my project. Thank you so much for listening.